Hey everybody, this is Larry. This is me going Q4 of the weekly contest 395. Find the median of the uniqueness array. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one, to be honest, don't be scared by the fact that the video is very long. I just wasn't able to get this during the virtual contest. I don't know why, to be honest. I kind of try to figure out, the number one thing that I always try to do, and I don't really, mind not getting it correctly, as long as I'm able to kind of learn something from it some way. And to be honest, I don't know. I think I'm just tired today. I did run a half marathon earlier in the day, and I did catch up a little bit on nap, but I think I was just not all there, to be frank, right? Because I think if I see this problem 100 times, I probably get it 95 times. And this is one of the other 5 times where I'm just having a rough day, I guess, right? Yeah, and I think that's the part that I don't know, some days you just can't do it. So don't worry, I will give you a good explanation, a good learning thing, and we'll get to it. Yeah. How did I? I don't know. But yeah, but the key part about this problem is there are a couple of key parts. I think the first thing is noticing that n is 10 to the 5th, right? And because n is 10 to the 5th, you know that you cannot obviously do anything even naive because n squared is a little bit too expensive, and that is no go. So the first, and you're trying to get also for this particular problem the median of n square numbers, basically, right? So immediately that doesn't sound like there'll be like you can't even generate all the numbers even if you have a really fast way, because the lower bound of generating all the numbers is going to be n squared, right? Even if you have a very fast got stuck on this one. It is very maddening, because I spent an entire hour and a half on this. I did get some hints and at the end, but yeah, let me actually rewrite this. Yeah, I'll use that as an example. But so the first idea that came to me immediately was binary search on the answer. If you are not strong enough on binary search, I definitely recommend you just solve a lot of binary search. I mean, I'm not gonna, I'm just trying to be straightforward with this video, which is that without binary search or without a strong foundation of binary search, you're not going to be able to solve this problem. And yeah, and there are easier problems to practice binary search than this one, right? So I don't know. So that, and I was actually weak on binary search on this one too, but that's besides the point. I would also say just an extra thing before I get into it is that I think in my recent video in the looking up my other channel, I do have a video about when to give up on a problem and stuff like that, and I did do the things that I said I would, which is that I asked for not a hint, but whether there is anything special that I needed to know. But sometimes, like if you have to, if this problem requires, Joe's algorithm, and I don't know Joe's algorithm, then you're just never gonna get it. But I just wasn't able to get it, and I think if I wasn't making this video, if I wasn't a content creator, if I wasn't an influencer, I say that really hilariously. If that wasn't the case, I probably would have slept on this problem and maybe like wake up tomorrow and then try again. Because I think sometimes, your head just gets stuck in weird places, and I think this is the problem here. So the first thing that I did during the contest is just to generate some smaller examples and kind of play around with it. But to be honest, I knew that it was binary search, and I knew that it was binary search on the answer. And you see me, if you watch the video, which I don't recommend because I don't think I learned anything other than like maybe the last 5 minutes or something like this, is that, I don't know, I just got stuck on, for some reason, for me, I just kind of, I don't know, just having one of those days. Like I said, 100% of the time, or out of 100 times, 95% of the time I would get it and get it pretty quickly. But for some reason, I just got stuck on this idea that I needed to know the distribution and try and build the distribution. And I just couldn't figure out a fast way to do it. And I just kind of, but don't worry, we'll go over it together. So for this one, like I said, you could do a binary search, but I'm going to use an example coming from linear search, right? First. So the idea here is that we're trying to get the median. And I didn't talk about this yet, but what does the median mean, right? So median means that given that n elements, so in this case, n is 8, right? That means that in the uniqueness array, in this array that they give you, or you're trying to calculate to a degree, it's going to be 8 times 9 divided by 2, so that's what? 4 times 9, that's 36, right? Yeah. Man, I forgot to. Yeah. Anyway. Oh, sorry. This is not n. This is n choose 2. And so there are 36 numbers in the uniqueness array. So that means that you're trying to find the median. And what does the median mean, right? Median means the number in the middle. But another way to say the median is that median is equal to the number that is greater than or equal to 18 numbers, right? Which is maybe 17 actually in this case, because you round down. But that's roughly it, right? So because it's 36, yeah, and you take half of them and you have to be greater than or equal to. In this case, it's the lower one, but yeah, right? And so now we try to do a linear search. Okay, can the answer be 1? Say, right? Can the median be 1? Well, the median so then here we will try to calculate what it means for median to be 1. The median is 1 if and there are a number of ways you can write this, but the median can be 1 if this thing, right? If the median can be 1 if it is greater than or equal to 17 numbers or something, right? Obviously. So then now we have to calculate, well, how many numbers is it greater than or equal to? Well, the answer is going to be, I'm just going to cheat a little bit here and say that it's going to be, we can calculate something, and the median is the number of numbers less than 1 is 0, right? Because, well, you can't have 0 in the array, so it just ends 0. And then now we ask, can the median be 2, right? Well, then now it gets interesting. Can it be 2? Well, the median can be 2 if, all these things, of course, right? And then now we calculate. Let's say we have this array. What does it mean to have 2, right? So here we will use sliding window. But for 2 is still not interesting because it can only be 2 if, if the uniqueness is 1, right? And the uniqueness is 1 only in one element, so then we could count it all up. So that means that the number of numbers less than 2, the number of uniqueness numbers maybe, is going to be 8, right? Because just 3 will be 1, just 4 will be 1, just 3 will be 1, ... And of course, if we had another 3, this would, also double up as 3, but we don't have it. We'll go over it soon, right? And we say, can the median be 3? Right, same thing here. So maybe I'll just ... this part. Right, the number of uniqueness numbers right? And now that means that we're trying to get uniqueness number of less than 3, which is 2, right? Basically 2 or fewer. Oh, this is not 8. Sorry, I just copy and paste. Okay, and then here, this part is, you can say is sliding window, but part of the sliding window, and I've gone over this in my previous videos. So hopefully you've been watching this month. I think it was 2 weeks ago. But the idea of this contribution, right? What do I mean by contribution? Meaning that for every number, what is its contribution to sorry, I have like allergies, and like my nose is like I need to whatever. But anyway, so for every number, what is its contribution to the answer? And the answer is just this question, to this specific question, right? So then now, given that it is the right n index, right? Meaning that it is the last element in the subarray, right? So then here, let's count. So let's say this is 3. Well, this answer is 1 because there's only one array that you can create, right? What about 4? Well, 4, we can actually create 2. We have 2 choices, right? Because here with only 4, we have the uniqueness number is 1. If we have 3 and 4, then the unique numbers is 2. So that means that we have 2 degrees of freedom, or 2 things to choose from. If the right n is 4, we have 2 choices to choose what the left n is. That's what I mean by degree of freedom. And in this case, this is 2, right? And then now this 3 gets a little bit interesting, right? Because then now, how far can 3 get? Well, 3 can actually go all the way to the left again, right? Because 3 is 1, by itself is 1, 3, 4 is going to be 2, 3, 4, 3 is 2. So that means that the 3 choices is for the left side of the array. This is plus 3, right? 4 is the same thing, right? Now you have 4 choices, because then this is going to be 1, 2, 2, 2, which is all less than 3, right? And then now 5 is the more interesting one now, because 5, it can only go up to 4, right? Because if it tries to go 5, 4, 3, then you have a 3, which is no bueno, which is already 3 or greater, which is not less than 3. And of course, anything that extends further can also not be possible, right? Because, well, it's at least 3 because it goes monotonically increasing. So in this way, this is also plus 2, because you only have 2 degrees of freedom. And the same thing for 3 plus the 3, now you only have 5. Oops. And so that's plus 2. You get the 1. The 1 is going to be only going up to 3, so that's also plus 2. The 3 only goes up to 1, so that, oh, actually no, I lied. The 3 goes up to the 3, and so that's actually plus 3. And together, this is a number. What's that? 10 plus 9? Is it like 19? I may be wrong. I don't know. I did it very quickly, right? So now the number of uniqueness of the numbers less than 3 is 19, and of course that means that because this is 19, that means that this number is bigger than the last number, and that means that 2 is the answer, right? Because that means that because you could think about it in a couple of ways, but the way that I would say is that, if 2 is not, if 8 numbers is less than 2 and 19 numbers are less than 3, then that means that the 9th number, the 10th number, 11th number, dot, all the way from that to 19 is going to be 2s. And of course that includes the number that has less than or equal to 17 or greater or whatever, right? 18 or whatever. So that's basically the idea, right? And so that's one thing. And this is if you do a linear search, right? Of course, a linear search is going to be too slow because this is O of n, and this takes O of n time, right, to calculate each one. So this is also going to be n squared. But of course, I already spoiled it for us, so I don't think this is going to be a thing, which is binary search, right? The key thing to note is that, okay, the number of unique numbers, it's going to be monotonically increasing because it goes from 0, 8 to 19. But if you also just think about it logically, because you go from, say, 3 to 4, well, this 4 includes all the numbers that that because less than 4 is just equal to the numbers of unique numbers that's less than 3 plus the number unique that is exactly 3, right? So of course this is going to be monotonically in greater than this, and as a result you could do a binary search on this, and after you do a binary search on it, you're able to get the answer. I'm doing a lot of hand wavy on the binary search because, like I said, by the time you get to this problem, you should be very strong on it. Even I'm not that strong on it, but if you could practice this on a more easier problem and then come back to figure out this part, because I think the tricky part about this part is calculating this number using this contribution idea. And oh, I skipped this a little bit, sorry, let me go back to it. But yeah, like I said, so you can't do this in linear time. I skipped this part, sorry. I'm tired, doing a lot of things wrong today. Because if you do it naively, like you go 5 and you just keep on going left to see what breaks, that's going to be n squared. But the idea here is that you can build up on binary search. Oh, sorry. Oh my God. On sliding window, right? For example, here you have 3, 4, 3, 4. And then now when you add the 5, you have 3 elements. And 3 is going to be too many elements. So then now you keep on shrinking on the left side until you have 2 elements, 2 unique elements, right? And the thing is that once you shrink, adding numbers to the right will never, the left side will never go back to more to the left, which makes this a sliding window candidate. And that's basically the idea. And that's pretty much it. So we'll go over the solution really quickly because I think the code is pretty straightforward, minus some binary search ickiness. But yeah. So this is the binary search. The good function is not very defined, but you can just pretend the good works. But the idea here is that returns true if for a target number there are fewer than median numbers less than less than target. What am I saying? Yeah, sorry. Right? So this is binary search. Like I said, I'm not going to get over that deeply. And here's the thing. So then basically this is just sliding window. And this sliding window is very... the sliding window part is pretty basic in the sense that... And I'm not saying that... I mean, you know... I'm just saying that in the sense that I think the same thing has happened in Q, like a medium difficulty problem on Leetcode before, on daily problems and stuff like this. So it's something that has happened many times. So you definitely should be familiar with this part of sliding windows and the number of unique numbers. And then the only tricky part is this count. And it is just basically what I call the degree of freedom. And when I say degree of freedom, I mean to choose the left side of, right? And of course, in that case, there are this number of things to choose from. And you kind of, go through why that is, right? Because if you have 2 degrees of freedom and you just work out the numbers. Yeah. Let me go over all the code. So this is the binary search. This is the top. This is the bounds. Median is this is actually not the median. This is actually n choose 2. The reason why I wrote like this is initially I had it like this, but I think it rounded the incorrect way. So then I removed this, and you can think about this as someone asked in the comments, but it's something like this, right? Because we want to get the median, but then I just multiply 2 on both sides to get this, and that's how I get this formula. But yeah, of course this is going to be linear time. There is a while loop inside a for loop, but of course this is very standard sliding window stuff. This is O of n, but this only increments n time in total because it is bounded by left, and so this is going to be O of n in total. So this function is O of n. This is a binary search. What are the bounds? The lower bound is 1, the upper bound is n, so this means that this is going to be log n. and this is n, so this is going to be n log n in total. But yeah, I think I'm just having a little bit of a rough day in terms of solving this because I don't know why I wasn't able to solve it. Like I said, I really, it's not that well, one is that I expect myself to solve it, but I don't even know how to learn from this because I should be able to solve it without even, like I learned nothing other than I'm like, I just got stuck mentally on like certain things and I don't know what happened. But yeah, that's all I have for this one. Let me know what you think. Let me make this comment, this window smaller so you could see the entire code. And this is the entire code. I think the top is just my comments and the definition. So this is my entire code. Let me know what you think. Thanks for watching. And you could watch me I didn't do anything for a while, so you could watch the next portion, skip ahead. There is a time early in the live portion where I do explain the binaries. Like I was like, this is binary search on the answer, but I just couldn't figure it out. I don't know why. Like I said, some part of my head is stuck. So yeah, thanks for watching, and you can watch me solve it live now. Boop. All right. Why did I? All right, YOLO. Okay. Silly. All right. I cheated by looking at this by accident. I usually try to avoid it. Okay. Find the median of the uniqueness array. You're given an intro array nums. The uniqueness array of nums is the sorted array. Oh, man, I have to read this slowly. I'm like saying the words and not reading. Okay. But luckily it doesn't count. I mean, it's a virtual contest, so and I already got a wrong answer. So yeah. Well. All right. The uniqueness array of nums is the sorted array that contains a number of distinct It is the sort of a consistency. Okay, I guess so. I mean, that makes sense. Here, distinct of num sub denotes the number of element that starts at I and j. Okay, also, guys, makes sense. Turn the median of the uniqueness array. What does that even mean? Okay. Median of the uniqueness array of nums. What does this mean? I actually missed this. I mean, I didn't miss it, but I just didn't read it correctly. Sort of array consists of, it's not just a subarray, it is all over I and j. So basically, okay. Oh, I see. And then it is the number of unique things, and then okay. I mean, obviously there'll be n ones, but there'll be n choose two things, so that's not. There's no. I mean. I don't even know how to think about this, to be honest. This is wild. It is a number between, I guess, just a distinctiveness. I mean, the numbers don't even matter. It is just the number of distinct items. Okay, so everything is different. I think this is going to be the distribution of all cases. You have your n, and then okay. What? Can we calculate every number? No, it's n squared. Oh, n choose 2. So the only way that this is 1 is if every number is unique. Is that right? Not even, maybe. Because in this case, oh yeah, no, not well, for very small n's. Okay, I think I know what I want to do. It's not the answer though. there's no pad time. Okay, so if you have distribution also matters, but I think I have to figure it out. Okay, so let's say they're all unique. I think that's the case I want to think about first, and then you have n ones, n minus 1 2s, and then n minus 2 3s. So then now we have a 4 that generalizes to and then now the median number would be, in this case, a 2. Is it binary? I mean, I have a feeling it's some sort of binary search, but I don't think I know yet. Gonna take a quick peek. Huh, people got it already. Wow, people are so smart. Well, I was pretty. Wow, people are so fast actually. Usually I'm faster, I feel like. But, oh, I guess that's with the wrong answer. Yeah, but even without the wrong answer, I was a little bit slow. But and then the distribution. I don't even have any ideas, to be honest. Like ways to attack. And people are already done. Well, okay. So in the most unique case, so is it just always 1 and 2? Like when is the answer 3? You always have n and then n minus 1. No, but it's n choose 2, right? So it's not quite right. So if you have enough unique numbers, I think that actually gets bigger, right? But, so it's n and n choose 2 is n times n minus 1 over 2. So then the median of that is n times n minus 1 over 4. Let's say we have 10 to the 5 number of items. What does that mean? Unique items. That is the upper bound of the answer, right? Okay, so okay. No, that's not right. What am I doing? N2 over. These are terrible names. So the answer could be 29,000. So actually it's way higher than I expected. So if I have a unique thing with 20, Can I do a linear binary search? I'm really not, wow, this one is just like, I don't know, blowing my mind, I guess. And one. Just roughly anyway, doesn't have to be exact. Median. Okay, what if we just take all the identical elements? So that's 3, this is 3, what does that mean? This 3 means that okay, I think I have an idea with all the intervals and stuff. Move a difference away. What does this 3 mean? 3 means that on the left we can do 1, 1, 2, 3, or 2. So then that means that for every 3 that we get, we depend on the position. So that means that for every previous 3 that we get, it's okay. How would that, the n squared one would look like that? Okay. Is it something I can optimize out? Huh. Well, people got this one way quick. I mean, a lot of people got this one. No, I'm just kind of stumped, to be honest. If this is the rightmost, then 4 we have 1, 2, 2, 2. So we can't even just go by seeing the 4s. Huh. Do I have an? I don't have an idea, but the median. Can I infer anything else from the median? Okay, so this is just the answer 3 for 3. Right? The sub thing is 3, and then now you add 1, 2, 3, and then another 3. Is that helpful? Can we merge unique components? Like 3, 4, 3, 4, 5. Does that help? The 3, 4 would have 1, 2, and then is there a sliding window answer? No. Man, I am stumped. Okay, let me reset. Do I need to calculate this away? Probably not, because there's n square things. I still feel like as a result it's binary search, but how do I binary search? How many 2 arrays are there? Can I figure that out? Does that help? Because all the sub-arrays of the 2's are not 2's. You have 3, 4, 4, 3, for example. What's the answer for 3, 4, 4, 3? Yeah. Oh, I guess 1 can be the answer because you have just all the same numbers. Is that a hint that I can use? Well, if they're all 1s, then the answer is 1. So the answer really can't be anything. What is it about median that I'm missing? I feel like I'm missing something really weird about median. How much time do I have left even? I have an hour, but I haven't done anything in like 20 minutes, which is kind of not great. I'm pooping up a bound on the answer, but that's not great. If this is a segment tree problem, I'm going to be sad. Divide and conquer? Is there divide and conquer? Divide and conquer does let you get the median. Yeah, I have no idea. But it feels like one of those problems though. Once you have an idea, you have an idea. we still have an hour left. This is gonna be a long hour. Okay. Does that really help? Basically, you can think about adding a number as adding a number is always going to be arranged with duplicate things, but depending on the previous position. But that's not enough. Is it? I mean, it's still n squared, but can I speed that up? The distribution matters, right? Let's add this thing, right? Then you have, let's say 1, and then now 2, 1, and then 3 you have 2, 2, 1. And then now this is just 2, 2, 2, 1. And now it's 1, 2, 3. Because this is a new number from all these. The 4 dupes here. So then it just takes this and then adds a 2. It's such an awkward thing. Three. 1, 2, 3, and then 3, 3, 3. Okay, well, that's, I don't know that that's that helpful. Okay, so then it goes to the next thing, and then, but what if, I feel like I'm missing a case here for it to increment, right? Let's say this. Let's just say there's a new number, and then it's just going to be, if it's a new number, it's 1 plus everything previous, which makes sense. Still, how do I even figure this out? Even if I am able to do this in all one time, what is the median? Let's say we do another 1, then it's going to be the same, but that's not helpful. Well, let's say we have a 3 again. 1, 2, 2. Now this is 1, 2, 2, 3. Is that right? Is that true that you just go to the next number? So you increment all the other ones to the next number? Is that true? Because then you already have a sequence that you always have. Can that give us a distribution? I don't know. I don't know how you would represent this though without another like for loop, so Man, I'm really missing. Like, it seems like everyone's getting this one, so I feel like I'm just like a little bad today. Maybe I'm just missing one visualization. I mean, there's a lot of people who got this right now. A lot of people, including Super Geo and Remix. Shout out, and they actually finished. It's nice to have a live scoreboard, actually, a live leaderboard. But a lot of people getting this. I don't. I'm really missing some key part of this. Thank you, half marathon. I don't know. I mean, it may be that yesterday I would have been able to get it. Who knows? But this is my. Maybe I just don't know something about median. I mean, okay. So then now we want to double all the previous stuff to get the median. Is that good enough? Can I do binary search on this? And how? Can I do a difference array on the difference array? So I could get one row at a time, but then I have to do some. Like, how do I? I mean, I don't know. Looking at the problem more does not seem to be able to help. Median. What does median mean? Can I pop stuff off on both sides? Does that help? Like, this stuff doesn't really help me, does it? Or I don't know how to do it faster than n square. Does getting the last row help anything? I don't think so, because I think the median here is like 3, but, or 2. Either 2 or 3, but either way, I don't know if that helps. Okay, so the max is going to be uniqueness. can I check how many ones there are? How many twos there are? How many threes there are? But the threes are kind of tricky, or starting to get tricky, because then you have this thing being a 3. And positions do matter, right? Does it? Does it? Am I missing some part of this? And let's say for no, but is that right? So the positions do matter. Just want to make sure that So I can't do anything like sorting and then just based on that. I guess maybe another example would have been like, I mean, immediately you have more ones, so that's going to be different. So is the distribution always the same? Okay, because okay, so let's say we don't have this, then we have just 4, 5. Because we remove the second 4, obviously the answer is the same, just like same as here. But putting the 4 here, what does that mean? This is the difference, is it? No, because 4 adds an extra 3 instead of 2 instead of 1. So that is the difference. So the number of unique things means that there is a distribution of that, and then doing the each dupes means that there's a shift in one of the so this force contribution, let's look at it that way instead of tail end contribution. Okay, so this force contribution is going to be 1, 2, 3, 3. This force contribution is going to be 2, 2, 1, 2, right? That's the thing that stands up. That will. Is that true? It's a little bit awkward, but everything else is the same. Yeah, well. Doing this way, and then this force contribution is just going to be 1, 1, 2, 3. which isn't quite right. I'm doing this a little bit wrong. Okay, let's rewrite this. Everything that this 4 is in is going to be in here. Okay. But this actually appears in more places, right? So that means that this 4 is going to be well, this row. And then it does affect the 5 though, so it's not quite just from this 3 to 2. The same way that this 4 may have 1 1, but then now this 3 makes it a 2. Well, I'm really not seeing it. I see the delta of it. So let's say we're at 3 4 5. We have basically 1 2 1 3 2 1, right? And then we have this thing. Okay, fine. Now we still have 3 2 1. And this is the delta. Okay, fine. And then now we have 3 2 1. And one of these 2 for 1. Alright, I mean, but what does that mean? It still doesn't give me enough, to be honest. The positions, I mean, I kind of make sense of it, but I don't think that's enough for me to solve it. This is a math question. I don't know enough about medians. Well, if nothing else, you can't say that these things are not authentic. Because I authentically have no idea. Is there a way to binary search? How can I binary search? The number of uniqueness is going to be No, I mean, you can't even put in a heap or something because the median is going to be like n choose 2 over 2. How are you able to? I'm stuck on binary search. Maybe it's not binary search. And I've done nothing in another 20 minutes. Let's try again. Okay, 1, 2, 3. It's gonna be 1. And then now let's say I convert this to 2. What does that mean? That doesn't really tell me enough. Am I thinking this in the wrong way? Probably. So the other way is so the median is always 1. Pigeonhole or something. Well, I mean, for 3 elements, I guess the median is always going to be 1 because of pigeonhole. So 4, the answer is going to be 1 and 2, I suppose. But given like 100,000, you can, all the numbers are basically possible. 29. Can I think of it as a negative thing? This 1 makes it so that it's just 1. We already went through this, Larry. I just have no idea. Just 7-pointer. Median still means what I think it means. This started off so well, but What other ideas do I have? I think that's the problem, is that I don't even have ideas to explore for half an hour. So there will always be this structure depending on n, right? So then it's just this other thing. Of the new numbers, the unique numbers, or the repeated numbers. If this is segment tree, I'm not going to be happy. Or like, because it's almost like, okay, it's almost like I have all these things, but I want to add this to it. I mean, if it's like some prefix, whatever, status structure, and then you binary search on it or something. It's still too slow, isn't it? It's almost like, I mean, yes, you can remove the 1 to the end, but there's still like a component of, still degenerate cases. I can't get that out of n square. You take out I don't know, maybe there's an idea that I can do this in segment things in like quicker time. Shift and add, but I could just get a lot. I don't know how to represent this in better than Otherwise, I mean, okay, so this part I do understand. But this form matters too, right? So it's not just. Yeah, I really have no idea. What other ideas do I have? Dynamic programming? No. Okay. Is there any other ways to get how many twos there are? Okay, so number of ones, pretty straightforward, maybe. Number of twos. This is a 2 too. And this is a 2. And this is a 2. And you can't just iterate on all different things. I mean, 600 people got this, so I don't know. What am I missing? Oh man, my watch is telling me to stand up. I mean, I went 13 miles, is that not enough? I don't think I misunderstood anything though. I feel like sometimes halfway through I'm like, oh, I misread this. This is just an hour of me doing nothing. Can you count backwards? Does that help? I don't know, I don't think so. What if I look at it differently? Okay. Say length 1, right? Length 2, no, it's just all 2s. Length 3, link 4. This may prone to error a bit. Should have just wrote a program to do this. I am an engineer after all. Link 5. That's private. Alright, well, maybe this is enough for me to think about it. Does this give me anything? Can I combine any of these? I mean, it's still too slow. It's still gonna be unscrew, even if I am able to do it that way. Man, today is not, I mean, I want to say today's not my day, but I mean, I just ran a half marathon, so I feel like it's hard to say it, but today is not my Leetcode day for sure. I mean, even the last one that I didn't solve, the Q4, like I knew I would do it. It was just a segment tree or what, or a sparse table one. This one I just have no idea. I don't even have any way to. What am I missing? Is it possible for me to solve it? I don't know. Like, does it have an idea that I don't know? Dun dun dun. I have the law and order sound in my head. Dun dun. I mean, you can't construct all of this because it's n squared, but is there a pigeonhole? Am I pigeonholing? Pigeonhole, pigeonhole, pigeonhole? What's the answer for this? I don't even know what the answer for this is. It's either 2 or 3, I think, because it's just from here. But the distribution matters. But how does it matter? Usually I have an idea that even if it's wrong, I can struggle with the wrong idea. I'm like literally doing nothing, which is kind of the worst part of this video. There are no learning lessons. I am playing around with it, but I mean, usually I would also try to write brute forces to get a pattern, but I don't think that helps here because I've kind of been doing it just manually. All right, let's write the brute force anyway. Let's have some homework to do. Yeah. What am I doing? I can't even remember what I wanted to write. Right. Where always forget about how this is this way. And this is the number of elements, inclusive. Okay, fine. Yay, we did it. Actually, we got it wrong. I mean, it's roughly right, but maybe I'm off by one on the answer. No, just to be clear, this is not right anyway. This is way wrong, actually. Why is that? Is this +1? Yeah, I always mess that up. Ah, now it is better though. Alright, let's play around with some stuff. I mean, I do know that if there's only one repeated number, then it's the structure is kind of interesting, but I don't know. I feel like I just don't know anything. Like Jon Snow. I know nothing. I have some. Let's just play around this one. Jon Snow, you know nothing. I don't know why it took me like an hour to do this. I feel like I could have been smarter about it. Just playing around with things. See what sticks. Should I put my name? That one is actually not this big. Just do it to name. How does this help? Is this always? Is it always in decreasing? I guess so. Is it true? No, I mean, I don't know, to be honest. Does it help finding what the decreasing factor is? How is this going from, like, how is this 7? Also, it's clearly increasing. What am I talking about? Not decreasing. So it probably. Oh, well, I mean, this goes increasing and then decreasing to a 5, but the 17 numbers, 2 is 24. I mean, that makes sense. Man, I have no idea. How much time do I have left? I'm not gonna lie. When the contest is over, I might just ask for one hint, and it's not a hint, just whether it requires something that I didn't know before. I think that's what I would like to know. Yeah, this is 4, but it's not the mode. The mode doesn't matter, but it's just that this is 84, I guess, and this is 69. Well, did not intend that, but nice. How would you figure it? How do you figure? How does this growth work? Well, we do it for length 1, of course it stays the same. Length 2, 7. I don't know. I'm not doing anything productive, to be honest. I feel like it's been so long since I've been so struggled. I mean, if I was able to do this in linear time, then this is pretty straightforward, but or n log n. I don't know that. I think that's the part that. I mean, this is clearly n squared is the part. I mean, I don't know. I really have no idea. I have 13 minutes. I'm going to just screenshot this real quick so that. Oh, wow. Because in a virtual contest it goes away. But wow. I mean, people got it very quickly. I don't know. So it's not like it's an impossibly hard problem. I just don't. I'm just missing 1 insight or something. Maybe 5 insights. What's it about median? And I'm still stuck on binary search. Is there like a divide and conquer thing? The merge step is too expensive. Man, I came on this video to embarrass myself. It's okay. I mean, I don't know how bad am I? I have had a streak of good ones lately, so I guess this is, you know, it's bound to kind of, you know, regression to the mean. And this time I don't even have to take a rating loss, so that's great. But I mean, this part is established. This part, okay, so then it's just this minus that. Okay, let's see. So that's 2, 1, oh no, 2, 5, 2. Is there a way to reason the 2, 5, 2 from this? No, I mean, this is the same thing that I've done, except for I did it manually earlier. I need a different way of thinking. And I also feel like this is going to be one of those problems. And I'm talking a lot now because I have no idea how to solve it. So in a way, I'm like wasting time, but I'm also just like, I don't know. But I also feel like this is one of those problems where I need like one thing. I'm like, oh, it's obvious, because that's the thing that I couldn't come up with. But you know, a lot of things are like that. I think once you know the answer, of course, it is obvious. Once you know the solution, of course, it's obvious. But uniqueness. Man, much disappointment. Oh, yeah. I mean, I don't know. I keep on trying to look at the problem to see if I maybe miss. Maybe I mean, that would be great if I misunderstood the problem because then at least I have an idea. I mean, it's sub array, so I didn't misread sub sequences, which happens a lot actually. Would that have changed with sub sequences? I don't know. I mean, we know what the anal. If this is some crazy union find, that would be pretty fun too. You have this idea of just merging, and then what would you do on a merge? Well, maybe nothing that productive. Smaller integrator. I'm just throwing out random words now, hoping one of them has an idea that sticks. I think I'm cooked though. Pretty not. Should have 8 first. That's my excuse. I'm sticking to it. After the marathon, I mean, I did eat actually, but should have ate a second meal before solving this. But should have also rolled the brute force a little bit earlier, though. I don't think it helps anything for me. That'd be funny if there is a Pythonic magic, but I don't think there is any crazy Python for me to do this uniqueness thing in a good way. I'm not built for an hour-and-a-half contest or an hour, no problem anymore. That's the part about getting old that it's a little bit tricky, is that your energy level is just trickier. I mean, I also say that, like I said, running a half a marathon, so maybe that also affects my energy level. But am I just waiting it out? Waiting it out seems like a waste of time though. Yeah, I think I'm just gonna ask for a hint in my Discord real quick. Okay, let's see. Does Q4 require anything I would not know? Alright, so I mean, I don't know if you're watching this, but if you're watching it up to here, I do have a video out about what to do when you get stuck on a problem. And the first thing I want to figure out for this one, I've effectively given up. I mean, I don't think it's virtual content, so I'm not gonna. I don't think I could code it up in 6 minutes, even if I know the solution anyway. But yeah, I mean, I want to know whether I can grind this through. I think that's my number one thing. Okay, so people tell me that I do know the technique or the idea, so which is actually disappointing. But okay. I mean, I think I'm just missing something. Like, what is something about median? I mean, I guess it's like a 2-pointer thing. Like you cancel ones with ends. Well, okay. I mean, so you have this base 1 to n thing, then only. Well, it's not that only that the other thing matters. It's just that you still have to factor that in. But that's an easy sequence to generate. It's the non-unique stuff that is tricky. The tricky part of the problem is tricky. Newsflash. Okay. Oh, let me just write facts. Just in case. Oh, I mean, try to be polite. So I mean, it's a sub thing of the one. I don't know. like I'm always tempted to do like a difference of. I mean, I what I want to do in my heart is some sort of like difference away, and like a difference away or something. But I don't know how to duplicate something in this kind of way. I mean, I have noticed some patterns, but I don't know. All right. Well, definitely when the virtual is over, I will have to. I will probably take a look at some ideas, because I think I did. I mean, I did say in my video that I would spend days on this, but I think this would make for a very long video, and I want to, as a that would be very awkward. If there's just like a 2-day video of Larry, and I don't even have that many ideas on this, though I'm supposed to be able to do it. It is a type of problem that I think, assuming that I know the answer, or I have the idea, or I have the ability to get the answer. Like I feel like I want to sleep on it, but it's probably not very good, interesting content. I mean, I don't. Let's make sure my at least that assumption is right. Yeah, okay. No, that assumption is right. So then when you add a number, it just kind of shifts the way we deal with this sequence. Because on the last number, yeah. I don't know. If I have to guess, let's go back to timing. If I have to guess, it's some sort of binary search. I don't know that that's true, but that was always my instinct. But I don't know how to do the search. Can I search on the length? Does that help anything? Don't think so. I mean, if if it did, I would have already done it. But Alright, I guess the rest of this video will be me trying to figure out how to learn in a precise way, or like in a, as few hints as possible. But a lot of people got it, so I don't know. It's just one of those forms, I suppose. Still, what am I binary searching on? If that, I mean, obviously, yes, obviously the answer, but how do you calculate the rest? You can catch up later, right? So what would the length help? Is there a length-based binary search that I could play around with? And the distribution do change the answers. We can't play it around here, right? Like just this, or it changes to I was gonna try a bigger number, but I guess. Am I also done? I am done. Let me try one more thing to visualize. So okay, so the answer is pretty. Oh, the expected answer's up, so that means that I'm done. Alright. I think what I'm going to do now is just take a peek at one of the answers and then see if I can get a peek of things. Where is C heavy? How did I not know that? It is binary search, but what am I? Okay. I mean, that's my hunch because none of the other things make sense. But how is it binary search? Okay. What am I binary? Okay. Well, I mean, partial credit, which is worth nothing, but still partial credit. Oh. What is there to binary search on? I mean, I knew it was binary. I wouldn't say I know, but I thought of binary search for like 40 minutes. I don't think, well, at least. So, I mean, that's not the game-breaking thing. I mean, I guess it's nice to confirm, but I was playing around with that for a long time, just because I ran out of things to play around with. Like what is it about this thing that am I generating, or even here, that allows us to binary search? Let's answer with this one again. This one which is 2. What is the binary search? I'm trying to think. And in the extreme case, n can be 15. Well, if n is 50, then it's 15 or something. How fast does that grow? It's n squared over 4 or something, but okay, fine. Honestly, I have no idea. I think maybe this is just one of those days where I need to cheat a little bit more. Let's see. I mean, this looks pretty straightforward. I mean, the binary search is obvious, I suppose, or like the actual binary search. Trying to find a mid, okay, and then count what's H. Oh, H is just what I would call mid, but okay, fine. And so, okay, I mean, so binary search on the answer, that's true. And you have a difference array? What is first? Hmm. I don't know how to get it. I think I have some idea about what it's saying, but I don't know that I understand it. Um, I mean, it's going backwards. Okay, fine. I mean, I don't know. Maybe it's just one of those days. Got it pretty quickly too, though. People write binary search in the most crazy way possible, but nonetheless. So you count the number of things that are smaller than I for some answer too. Well, I guess that makes sense, but I see. I guess so. That's what I was trying to. Is it though, Larry? Are you lying to yourself? Maybe I'm just maybe I'm just not understanding this problem correctly. Um, okay, let's say I'm binary searching for 3. What am I doing here? Right, and I have 2 ways of constructing this. We have 3. Um, well, I mean, back and forth doesn't really matter, but I say I'm binary searching for 3. Right, so 1. Now we know that we have 2 numbers that are less than 3. Just because we have 2. And then, okay, and then 3. Okay, so 2 numbers. The 3 now means that because it is the same as this. Okay. The 4 also has under 3. Okay, and then 5. We haven't seen anything. How do I get the 3 from here? Or count of things less than 3. So then you do sliding window, and then everything in before that. What does it say about stuff before that? Do you do sliding window? If we do sliding window, what does that mean? that means that everything on top that is going to be bigger than, is that true? Well, yeah, because you're keeping it small. All right, let's try. Okay. Maybe I'm, yeah, okay, maybe I'm just having an off day. I keep saying that as if like my good days are really good, but alright, let's, I mean, it's better than nothing. What, my good days, I'm pretty okay. Okay, good means that it is, I always get these a little bit off. So you want to return the exact number of things smaller than, well, n over, or n choose 2 over 2. And then, so if this is good, we want to try a smaller number, right? I'm just being really bad about this. Okay, now what am I doing? Right, okay, sliding window. Okay, now I feel dumb. But yeah, okay, maybe, I don't know. I don't know if I'm still right, but it is still sad in any case. Oh, numbers. Let's go right. Something like, oops. Is it greater than or equal to? I'm always so bad at this. If it's equal to, now you want, no, yeah, it was equal to. I really should know this. Why did I? It's just okay. Keep on saying it's one of those days, but I guess it is what it is. Okay, and then now, left to right is going to contain. Okay, so then now +1 maybe? Why do I have a parens? Where am I? Oh, median. What is it? Does that work? I mean, whatever, close enough. Let's at least see if it gives me a good enough number. What am I doing? 39. Index out of bounds. Why? Wait, what? 39. Oh, because target could be 0. Is that right? Alright, it's not quite right, but I want it. So we target 2. We should return 3. We return 3, we're happy, we go look. Oh, I guess I should not check the one that has the right answer, but alright, so for this one, 2, we median is 7, okay. That's true, right? Yep. And count is 5. Oh, I think I think this is fine-ish. I think this is the number. Okay, that means that I have to. All right. Well, that's just well. Thanks, friends. 2, 3, and 5. What? I mean, this gives me the number of things that is. No, for T it returns 5. I mean, 1 is 0 is reasonable. Why does it return 5? Because that's 5 once? I guess that's true. So that means that I am just doing this thing incorrectly. So I'm failing on binary search anyway. I'm always so bad at the discrete ones. Okay, so 5, that means we want to try a big, wait, so that means this is force. Want to try a big, so we do try a bigger number, don't we? Is this, there might, oh no, median is, did I get the signs wrong? I'm failing on the dumb part. Okay, that's not it. Okay, so we have 5. This is embarrassing, but okay. Because why doesn't this work? Because then now this should return the next bigger number, and then actually that's just wrong, right? V5. That's right. I mean, at least the binary, the good function is right. So I don't know why. I don't know. Just one of those days. I probably should have. I think this is one of those things. If I slept on, I would have gotten it. But because I was. I don't know. Because it's so obvious once I do it. But okay. Still. So for 2, it returns 5 because there's 5 things that are okay. So that means that if it's good, we actually want to try a smaller number, right? Wait, what? Am I just like bad at binary search? I'm just, I don't know, maybe my brain is fried today. So this gives us, because this is mostly right, I think. So this gives me 5. We need 7, so then am I just dumb? So if this is good, because it is smaller. Then we, what am I doing? What am I doing with my life? Is this right? Am I just being funky? This is just wrong. I am not having the power for this because this is just, I mean, this is a little bit better. Actually, I think this is more right, but, oh, because this is equal. I see. If this is exactly equal, what do we do? I mean, maybe still off by once, but I think the idea is right. I mean, I don't know. I don't know why this is wrong. I mean, I think I'm just like missing some edge cases. Yeah, like 27 exactly, and I'm returning the wrong thing. Which is fine. I mean, this is doable. It is just me being dumb. Oh, because it's odd even thing. Yeah. This off by one on the median. Dumbness. How did I miss this? That's the problem. I mean, to be honest, like half the time I'm typing this, I'm just trying to think how I missed this. I was looking at this. I knew I had to binary search at the answer, but for some reason, I guess I just got this idea stuck in my head that I needed to know the distribution instead of just to count numbers smaller than it. Like I had all the components, just one of those days. I keep saying it because I want to believe. I keep saying it because I want to believe I'm not dumb, but maybe I am. Who knows? How does this happen? I don't know. Like I don't get it. I mean, it's not that I don't get it. It's more that I'm like half the time, like I did cheat a little bit, obviously, but some of the cheating is just like, well, I think to be honest, in a weird way, I think I clicked on the ones that are like not very descriptive, because I did not do it this way anyway. I mean, this is just like a very funky way of writing it. So I don't think I learned that much from this, even though, I mean, it obviously is correct. Whose was the other one that I clicked on? I think I clicked on the Python one or something, that's why. Maybe this one? No. Unclear which one I clicked on, but I clicked on two. And it was kind of good in a way because it didn't really give me enough. And I think at some point, I mean, I did get a hint. The hint was that I did not need to know the distribution, or like a reminder, I suppose, maybe. I don't know how you want to phrase it. And as soon as I noticed that, I was like, I don't know. It's just one of those days. But yeah, yeah. Don't really have much to add to this one. I mean, wow. I mean, I can see why 600 people got this, or 700 almost even. But I'm glad that I didn't do it. I don't know, because it's not like, because the way that I think about these things also is that there's a probability, from 0 to 100%, because that's how probability works, of me getting any given problem at any given day. I mean, I don't think this is 0. Clearly not 100 either, though, but how did I mess this up? I think right now I'm just trying to do like a post-mortem or retrospective kind of thing of like, because I knew what I knew how to, or I knew the idea, so it wasn't even that. I mean, sure, I did have a lot of uncertainty about it, but I knew it was binary. Or I didn't know, no, but I had a hunch it was a binary search. I even knew it was going. I mean, once you know it's once you guess that's binary search, it can only be binary search on one thing, right? So, how did I miss this? Hmm. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this explanation video, this contest, every in between. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.